Hello students, today I am going to discuss Cambridge O-level chemistry year October-November 2021, paper 22. Paper 22 ON 2021. Please subscribe, like and share my channel. Press on playlist to get your own content. Let's move. Number 1. Choose from the following chlorides to answer this question. Here some chloride compound are given: aluminum chloride, ammonium chloride, cobalt 2 chloride, and hydrogen chloride, iron 2 chloride, potassium chloride, silver chloride, sodium chloride. Each chloride may be used one more or once or not at all. State which chloride contains a cation with charge of +2. Cation is +2. So here cobalt 2 chloride, COCl2. So here cobalt oxidation number is +2. So this will be cobalt 2 chloride. B. Reacts with aqueous sodium hydroxide to form a red brown precipitate. And this iron, this answer will be iron 3 chloride, because iron 3 ion reacts with sodium hydroxide to produce iron 3 hydroxide red brown precipitate. Iron 3 hydroxide is a red brown precipitate. Number C. Is insoluble in water, and silver chloride is insoluble. Is insoluble in water, silver chloride is insoluble. Silver chloride is, this is solid, white precipitate, white solid, so this is insoluble in water. Now number D. Reacts with sodium hydroxide when warmed to produce a gas which turns damp red litmus paper to red litmus paper blue. Alkaline gas. This will be answer will be ammonium chloride. To ammonium chloride, if you add sodium hydroxide alkali, ammonia gas will be produced. Sodium hydroxide NaOH, they react to form salt plus ammonia gas plus water. Ammonia gas, NH3 gas, it is alkaline gas which turns damp red litmus paper to blue. So this answer will be ammonium chloride. To any ammonium compound, if you add sodium hydroxide and gently warm, salt plus ammonia plus water will be produced. This ammonia alkaline gas is turns damp red litmus paper to blue. Now E, when added to water, can form an aqueous solution with a pH of 1, I mean a strong acid. And you know, hydrogen chloride gas, if you add in water strong acid, hydrochloric acid, aqueous solution is formed, which is a strong acid. That's why pH value is 1. Let's move. Number 2. This question is about pollutant gases. A, hydrocarbons, say octane, are used as a fuel for cars. The list shows the gas present in the car exhaust: carbon dioxide, carbon monoxide, nitrogen, nitrogen dioxide, octane, water vapor. Now state which two gases in the list below that incomplete combustion has taken place in the car engine. Two gases, carbon monoxide and octane gases, unburned. Octane is a hydrocarbon, unburned hydrocarbon gases are produced. B, describe a test for the carbon dioxide. You know, carbon dioxide turns lime water milky. So test will be carbon dioxide gas is passed through lime water. Carbon dioxide gas is passed through lime water. Result will be observation: lime water turns milky. Milky means cloudy, white precipitate is formed. That's why lime water is colorless. Calcium hydroxide is lime water. It will turns milky because calcium carbonate is formed, which is cloudy or white precipitate. Now see, two natural sources of methane in the atmosphere are from leaks of natural gas and waste gases from animals. Give one other natural sources of methane in the atmosphere. Decomposition of plants. Decomposition means breakdown of plants. Decomposition. Decomposition of plants produces methane gas. This is the natural sources. And D, complete the sentence about the effect of an increase in the concentration of methane in the atmosphere. If concentration of methane increases in the atmosphere, so now methane is a greenhouse gas because it absorbs and then re-emits infrared radiation. Methane gas absorb first, then re-emit. This contributes to an increase in temperature of the atmosphere, which is called global warming. You know what is global warming? This methane gas is absorbed, then re-emit, which increases the temperature in the atmosphere, means this is known as global warming. Now E, cars are fitted with catalytic converter to reduce the amount of harmful pollutant gases from car exhaust. Polluted gases are converted to less polluted, less harmful gases. Describe how catalytic converters remove pollutant gases from cars. Pollutant gases, say nitrogen monoxide is a harmful gas and carbon monoxide, react to form less harmful gases, nitrogen and carbon dioxide. Means nitrogen monoxide is a harmful gas. Nitrogen monoxide reacts with carbon monoxide to produce nitrogen and carbon dioxide. So nitrogen monoxide is most harmful, carbon monoxide is most harmful. These two pollutant gases react to produce less harmful gases. Nitrogen is harmless and carbon dioxide is less harmful gas compared to nitrogen monoxide and carbon monoxide. Now number 3, magnesium ribbon reacts with hydrochloric acid to produce magnesium chloride, salt and hydrogen gas. So the graph shows the volume of hydrogen gas produced as 20 degrees centigrade as reaction proceeds. This is the graph. Volume of hydrogen gases with time. Volume is increases with time, this graph. Now you are asking, the experiment is repeated using a lower concentration of hydrochloric acid, and you know lower concentration, so reaction will be slow and less amount of product will be produced. The volume of acid used and all other conditions are the same. Draw a line on the grid to show how the volume of hydrogen gas produced with time when the reaction is done at a lower concentration of hydrochloric acid. You know, if concentration increases, if concentration decreases, number of particles per unit volume decreases, so less effective collision occurs, rate of reaction will be less and product also will be less. So this graph will be at lower concentration, this will be the graph less steeper compared to previous one. From this will be low concentration. Now B1, describe and explain using ideas about collision between particles how the rate of reaction changes with magnesium powder is used instead of magnesium ribbon. You know, magnesium powder has magnesium powder has greater surface area, so rate of reaction increases. If magnesium powder is used, rate of reaction will be more, rate of reaction higher, increases, because more particle exposed on surface. If surface area increases, more particles exposed on surface, so more successful collision occurs per unit time. So more successful collision occurs per unit time. So if magnesium powder is used, rate of reaction increases because more particle exposed on surface. More particles exposed on surface, so more effective or more successful collisions are occurred per unit time. Now next one, describe and explain using ideas about collision between particles how the rate of reaction changes when the temperature of the reaction decreases. And you know, if you increase temperature, rate of reaction increases, and if you decrease temperature, rate of reaction decreases. Now answer will be rate of reaction decreases. Why? Because particles have less kinetic energy. If you decrease in temperature, particles have less kinetic energy, so less collisions are successful or fewer collisions are successful. That's why rate of reaction decreases. Now calculate the maximum volume in dm cube of hydrogen formed when 1.68 gram of magnesium react. Magnesium mass is given. You are asking calculate the volume of hydrogen. So as mass is given, so you will use solid formula. Mole of magnesium, I mean number of mole of magnesium, mass of magnesium divided by molar mass of magnesium, 0.070 mole. So volume of hydrogen, moles of magnesium and moles of hydrogen, mole ratio same. This equation this moles of magnesium is 1 mole, moles of hydrogen 1 mole. So number of moles of magnesium will be the same of mole of hydrogen. So now you see moles of hydrogen will be same. Moles of hydrogen will be same. Now volume of hydrogen, number of mole of hydrogen times molar volume of hydrogen. Molar volume of a gas at room temperature 24 dm cube. So answer will be 1.68 dm cube. So now magnesium is a good reducing agent. Describe a test for a reducing agent. You know, reducing agent reduces another substance but itself oxidizes. So test: acidified potassium permanganate, potassium manganate 7 or potassium permanganate solution is added. I mean KMnO4, acidified KMnO4 solution is added. Observation will be solution turns from purple to colorless. Potassium permanganate reduces another substance. Reducing agent reduces potassium permanganate to manganese 2, Mn2 plus. So if you add reducing agent to potassium permanganate, that reducing agent reduces KMnO4 to manganese 2. This is colorless. So observation will be purple solution turns to colorless. This is the test for reducing agent. Now next, for alkanes are homologous series of hydrocarbons. The boiling point, melting point, density of alkanes increases as the number of carbon atom increases. So A1, give one other physical property of alkanes which increases as the number of carbon atom increases. Another physical property is viscosity. As carbon number increases, so their viscosity increases because their intermolecular force increases. Now give two other characteristics of a homologous series, same functional group. You know, this is the characteristics of homologous series, same functional group and same general formula. Same functional group and same general formula. Number B, two typical reactions of alkanes are combustion and cracking. State the name of another typical typical chemical reaction of alkanes and the reactants needed to react with the alkanes. And you know, type of reaction is substitution reaction, reactants chlorine. You know, alkane reacts with chlorine to form chloroalkane plus hydrogen chloride. Alkane reacts with chlorine in presence of UV light to form chloroalkane plus hydrogen chloride. This type of reaction is known as substitution reaction. Reactant is chlorine. Number C, alkenes are produced by cracking alkanes. State two conditions needed for cracking. You know, for cracking high temperature is needed and catalyst also needed. High temperature and catalyst are needed for cracking. Here tridecane can be cracked to produce an alkene with 4 carbon. 4 carbon alkene is butene and one other high hydrocarbon alkane. So if alkene 1, another will be alkane. Total 13 C4, 13 minus 4, you will get 9, carbon 9, hydrogen 28 minus 8, you get 28. So this is alkene, this is alkane. Left hand side 13 carbon, right hand side 4 plus 9, 13 carbon. Left hand side 28 hydrogen, so 8 plus 20, 28. All carbon and hydrogen atom on both sides are equal. Now a hydrocarbon contains 88.9% carbon. Hydrocarbon, you know, compounds containing carbon and hydrogen only. So carbon is 88.9, hydrogen will be 100 minus 88.9. This will be 11.1. Then divided by their relative atomic mass, air, carbon 12, hydrogen 1, you will get 7.4, 11.1. After that you divided by the smallest one, 7.4 divided by 7.4, you get 1, and 11.1 divided by 7.4, you get 1.5. So carbon is 1 atom, hydrogen is 1.5 atom. This is a fraction. So you will multiply it by 2 to convert whole number. 2 ones are 2, 1.5 times 2, 3. So here 2 carbon atom, C2, hydrogen 3. This empirical formula will be C2H3. Okay, next one. Lithium reacts with aqueous zinc iodide. Lithium iodide plus zinc is formed. Explain by referring to the equation why this reaction involves both oxidation and reduction. You know, lithium here oxidation number 0, here lithium plus 1, iodide minus 1, zinc here plus 2, here 0. So lithium is oxidized 0 to plus 1, that means it lose electron because it lose electrons. Zinc ion, zinc 2 plus here 0, zinc ion are reduced because it gains electron. Here lithium oxidized because it lose electron, zinc ion reduced because it gains electron. That's why this reaction involves both oxidation and reduction. Yes. B. Acidified aqueous silver nitrate is added to zinc iodide. You know, silver nitrate is the test for halide ion. So if iodide ion present, silver iodide yellow solid is produced. So state the observation made, yellow precipitate is formed. Yellow precipitate is formed. Now CO1, when aqueous bromine reacts with aqueous zinc iodide, a brown solution is formed. Name the products of this reaction. You know, bromine reacts with zinc iodide. Zinc iodide, zinc bromide, plus iodine is produced, because bromine is more reactive than iodine, so bromine displaces iodine. Zinc bromide and iodine product are produced. So name the product. One product is iodine, other product is zinc bromide. Number 2, explain why aqueous bromine does not react with aqueous zinc chloride. Bromine reacts with zinc chloride. So here bromine is less reactive than chlorine, so bromine cannot displace chlorine. That's why this reaction not happen. So answer will be bromine is less reactive than chlorine. Bromine is less reactive than chlorine. Now phosphorus react with hydrogen to produce phosphine pH3. This reaction is endothermic reaction. I mean delta H will be positive, change in enthalpy will be positive. So complete the diagram, energy profile diagram for this reaction. Label reactants, products and delta H. So this is the diagram. Endothermic as product has more energy, reactant has less energy. Reactant has less energy, but product has up to this energy. That's why this is an endothermic reaction. Product has more energy, reactants below, products above. Now these are reactants, these are products. Enthalpy of the reaction, the energy difference between reactant and product, delta H, this is positive, you can write above arrow. So B, explain in terms of bond breaking and bond forming why this is an endothermic reaction. You know, bond breaking endothermic, bond breaking energy is needed, and bond making exothermic means energy is produced. Here more energy is absorbed than released. Here need more energy than released. That's why this is an endothermic reaction. More energy is needed than produced. Next, here complete the equation phosphine, oxygen, phosphorus 5 oxide plus water. So how you balance? Here 4 phosphorus, so you write here 4. Then 4 3s are 12 hydrogen, so you write here 6 2 the 12. Then oxygen 10 plus 6 16. If you write here 8 to the 16. 4 phosphorus, you write here 4. Then 3 times 4 12 hydrogen, you write here 6. Now oxygen 10 oxygen plus 6 oxygen, total 16 oxygen. If you write here 8 to the 16. This equation is balanced now. Now number 7. Sodium is a metal of group 1, metal in group 1. Diamond is a non-metal which is a good conductor, non-metal which is a good conductor of heat. State two differences in the physical properties of sodium and diamond. Sodium is a metal of group 1, diamond is a non-metal which is a good conductor of heat. Now state two differences in the physical properties of sodium and diamond. Differences: sodium conduct electricity, sodium conducts electricity but diamond does not conduct. Sodium is a metal, is a malleable, but diamond is not malleable. Two differences you can write. Then B, an ion of sodium is given, sodium ion. So number of proton equal this number of proton number, atomic number is the number of proton, 11 is the number of proton. Number of neutron will be 23, mass number minus 11, you get 12 number of neutron, and number of electron will be 10. Why? There are proton number 10, proton number 11, so plus 1 means 1 electron less. Number of electron will be 11 minus 1, it will be 10. Sodium reacts with nitrogen to form sodium nitride, Na3N, nitrogen balance is 3. So complete the equation. How you write this equation? As 2 nitrogen, so you write here 2. Now there are 3 to the 6, 6 sodium, balanced. Next, when carbon is heated with steam, carbon is heated with steam in a closed container, an equilibrium is formed. Carbon reacts with steam, carbon monoxide and hydrogen gas is produced. Here carbon is solid, water gas, carbon monoxide gas, hydrogen gas. The forward reaction is endothermic. You know this delta is value is positive, so this is endothermic. Now describe and explain the effect, if any, on the position of equilibrium when the temperature is increased. If you increase temperature, position of equilibrium will move from which direction? So as this reaction is endo, it will move from left to right. Equilibrium moves to the right, I mean left to right. Why? To absorb heat or for absorbing heat. If you increase temperature, reaction will try to decrease temperature, try to absorb heat. So as this is endothermic reaction, if it go left to right, it will absorb heat. That's why answer will be left to right for absorbing heat, to taken in heat, to decrease the temperature. Now to describe and explain the effect, if any, on the position of equilibrium when the pressure is decreased. You know, if pressure is decreased, equilibrium will move to the greater number of moles, more number of moles. Now pressure is decreased, you count number of mole. Here 1 mole gas, here solid you will not count. Left side 1 mole, right side 1 plus 1, 2 mole. So right product side has greater number of moles. So if you decrease pressure, equilibrium will move from left to right. Now see the answer. Equilibrium moves to the right as there are more gaseous molecules on right hand side than on left. Equilibrium moves to the right because there are more gaseous moles on right hand side. Next, number 8. This T is an organic compound. T is an organic compound. Deduce the molecular formula of T. You know, molecular formula shows the whole ratio of atom, whole number of atom. So you count 3 carbon, 1, 2, 3, 3 carbon. Hydrogen 1, 2, 3, 5, 6 hydrogen and 1 oxygen. So molecular formula will be C3H6O. Now B, compound T is a colorless liquid. State the color change when excess compound T is added to aqueous bromine. And you know, compound T has carbon-carbon double bond, so this is unsaturated compound. If you add bromine water, aqueous bromine, the observation will be orange bromine solution turns to colorless. So your observation will be orange to colorless. This is the alkene test. Any alkene, any carbon-carbon double bond containing compound, if you add aqueous bromine, observation will be orange to colorless. Now see, compound T can be oxidized to a carboxylic acid. State a suitable oxidizing agent for this reaction. Oxidizing agent, this is the alcohol, primary alcohol, so you can write potassium manganate 7 or KMnO4. KMnO4 is an oxidizing agent. If you add, then alcohol will oxidize to carboxylic acid. Or you can write potassium dichromate K2 Cr2O7, potassium dichromate. Then alcohol will be oxidized to carboxylic acid. Now D, compound T can be polymerized. draw the partial structure of this polymer form of compound T. You have to show 2 repeat units. So this is addition polymerization, as this contains carbon-carbon double bond. So this double bond will be single bond, one bond will be open left hand side, other bond will be right hand side, then another molecule will be added as like this, CH2OH. This will be single bond. Now you see, yes, same, C bond open, this carbon contains 2 hydrogen, double bond becomes single bond, this carbon contains CH2OH, this carbon hydrogen, bond open, another repeat unit is added to this. This is the 2 repeat unit, one repeat unit, another repeat unit. This is addition polymerization. Now compound T is alcohol, reacts with methanoic acid HCOH to form star. Complete the structure. So this given, up to this given, then alcohol will lost OH group, acid lost, methanoic acid lost will 1 hydrogen. So methanoic acid alcohol lost OH group, acid lost hydrogen ion, then you added, after this bond open, O CO CO H. This is the structure of this star. Now methanoic acid is a weak acid, hydrochloric acid is a strong acid. You know, weak acid ionizes partially and strong acid ionizes fully. Number 1, give the formula of the positive ion that is present in all acid. Acid contains hydrogen ion H+, this is known as proton. All acid contains hydrogen ion H+ ion. Now number 2, explain why the rate of reaction of 1 mole per dm cube methanoic acid with magnesium is less than the rate of reaction of 1 mole per dm cube hydrochloric acid with magnesium. Because methanoic acid is a weak acid, so it will produce less hydrogen ion. So methanoic acid has a lower concentration of hydrogen ion because methanoic acid ionizes partially. That's why rate of reaction will be less. Number G, construct the equation for the reaction of methanoic acid with magnesium. And you know, any carboxylic acid reacts with metal to produce metal salt of carboxylic acid plus hydrogen. Metal salt of carboxylic acid plus hydrogen. So here this hydrogen is replaced by magnesium balance is 2, that's why I write here 2. Then hydrogen produce gas. Any carboxylic acid reacts with metal to produce metal salt of carboxylic acid plus hydrogen. Metal salt of carboxylic acid plus hydrogen. and observation will be fizzing occurs, bubbles of gas, and metal dissolves. Magnesium, if it react, magnesium will dissolve, or you can write solid dissolves. Okay, now next 9. About the sulfuric acid and sulfates. A1. Sulfur is one of the raw materials used in contact process to make sulfuric acid. Name two other raw materials used to make sulfuric acid. You need air, oxygen is needed, and you need water needed to dilute the sulfuric acid. Fuming. To dilute the fuming sulfuric acid, I mean oleum, so water is needed. Name the catalyst used in contact process. You know, vanadium 5 oxide is needed, V2O5. Vanadium 5 oxide is needed. Vanadium 5 oxide is needed. Now B. The electrolysis of dilute sulfuric acid using inert electrodes produces oxygen at the anode. Now question is asking, define the term electrolysis. You know, the decomposition of an ionic compound using electricity, or the breakdown of an ionic compound by the phases of electricity is known as electrolysis. And number 2, construct the equation for the reaction that take place at the cathode. And you know, at the cathode reduction reaction occur. Hydrogen ion gains 2 electron, 2 hydrogen ion gains 2 electron to produce hydrogen gas. This is a reduction reaction because hydrogen ion gains electron gain, reduction reaction occur. And you know, at the cathode reduction reaction occur. This is cathode reaction, as at cathode reduction reaction occur. You see, now this is calculation. Dilute sulfuric acid reacts with sodium hydroxide to produce sodium sulfate plus water. A student adds 0.6 gram of sodium hydroxide. Sodium hydroxide mass is given to 45 centimeter cube, 0.20 mole per dm with sulfuric acid. Here sodium hydroxide mass given, sulfuric acid volume and concentration is given. So first of all, moles of sulfuric acid concentration times volume. 40 centimeter cube has been converted to dm cube by dividing 1000. So you get now moles of sulfuric acid this. Then moles of sodium hydroxide, mass 0.70 divided by 40. 40 is sodium hydroxide relative molecular mass, sodium 23 plus oxygen 16 plus hydrogen 1. This is the, you will get 40. So you get 0.019. But your mole ratio, see, 1 mole sulfuric acid reacts with 2 mole sodium hydroxide. Now show by calculation that sodium hydroxide is in excess. So sulfuric acid mole 0.009. So for 0.00 mole of sulfuric acid, sodium hydroxide needs 2 times So you will get 0.18. So you need 0.018. Sodium hydroxide need 0.018 mole, but sodium hydroxide has 0.019 mole. So sodium hydroxide is excess because 0.19 is greater than 2 times of sulfuric acid. 0.09 equal 0.018. 0.018. 0.1019 is greater than 0.018. So moles of sodium hydroxide is in excess. Next, aqueous sodium hydroxide is warm with ammonium sulfate. State the names of the 3 products from this reaction. You know, ammonium sulfate, this is an ammonium compound. Ammonium sulfate if you add sodium hydroxide, you will get 3 products: salt, sodium sulfate, plus ammonia plus water. 3 product you will get. Any ammonium salt, if you react with sodium hydroxide to produce salt, sodium sulfate, ammonia plus water. So any ammonium compound, if you add sodium hydroxide, salt plus ammonia plus water will be produced. Now next, number 10. This question is about element of group 5. Their element name: nitrogen, phosphorus, arsenic, antimony, bismuth. This is a group 5 element. Density is given. Density increases and melting point increases, again decreases. This is not a regular trend. Now use the information in the table. Predict the density of antimony. This density how much? So you can write 9.12 or 6 to 9.50, any values. How you get this value? These are increasing, so what the difference? 5.73 minus 2 point, difference is 2.34. So this is the difference 3.39. Now from up to down increases. This difference you add with this value 3.39 plus 5.73. This value if you add, you will get 9.12. So this is the answer, 9.12, or any values from 6 to 9.5 you will get mark. Now you see, suggest why it is difficult to predict the melting point of arsenic. Answer, there is no trend down the graph. No trend means there is, it increases or decreases, but it happen both. You see, melting point increases but again decreases, so there is no regular trend. That's why you cannot predict. Answer will be, there is no trend down the graph. There is no clear trend. Now the structure of two compounds, phosphorus R and S, are shown. This is the R, positive ion, negative ion. This is the ionic compound. This is phosphine, simple molecule. Now question is asking you, explain in terms of structure and bonding why compound R has a high melting point and compound S has low melting point. You know, compound R is a ionic compound. There is a strong attraction between opposite ions. Or S is a simple molecule. There is weak intermolecular forces between molecules. So your answer, you see, compound R, this is R. R is a ionic compound or ionic structure. There is a strong attraction between opposite ions, or you can write there is a strong attraction between positive ion and negative ion. So it has high melting point. That's the reason. Compound S is a simple molecular structure because it has low melting point. So compound S is simple molecular structure. There is weak force of attraction between molecules, or you can write there is weak intermolecular force between molecules. There is weak intermolecular force between molecules. You know, any ionic compound, there is a strong attraction between opposite ions, between positive ions or negative ions. So a lot of energy is needed to overcome this attraction. That's why melting point is high. The molecules which are simple molecular or simple molecule, there are weak intermolecular forces, so less energy is needed to break these forces. That's why simple molecule has low melting point. Now let's move. Number 2, explain why compound R conducts electricity when molten. You know, compounds R is an ionic compound. Ionic compounds conducts electricity when molten because in molten states the ions can move. The ions are able to move. The ions become free to move in molten state. But in solid state, the ions are in fixed position. They cannot move. That's why when molten compound are conduct electricity. Why? Because ions can move freely. Ions are able to move. Next, draw a dot and cross diagram for a molecule of S. S is a sim pH3 phosphine. So phosphorus here, 3 hydrogen, 1 electron give phosphorus here, another electron, 3 bonding, 3 bond. Phosphorus is a group 5 element, so it has 5 electrons in its outer shell. 1, 2, 3, remaining 2 here. This is non-bonding electron or lone pair electron, non-bonding, who is the electron which does not form bond. And hydrogen only has 1 electron. This give cross 1, 2, 3, 3. This is the dot and cross diagram of molecule of S, phosphine. Now an oxide of phosphorus has the formula of this P4O10. So calculate the percentage by mass of phosphorus in this compound. Molar mass MR means relative molecular mass of phosphorus 5 oxides 284. How is get? Phosphorus relative atomic mass 31 times 4. There are 4 phosphorus plus oxygen 10, 16. Oxygen relative atomic mass 16 times 10. So if you add, you will get relative molecular mass of phosphorus pentoxide 284. Now percentage by mass of phosphorus will be in 284. There are 4 phosphorus atom. In total 284 gram of phosphorus, there are 4 phosphorus. So 31 times 4 divided by 284 times 100. Total 43.7%. Total relative molecular mass of phosphorus pentoxide 284. In 284 gram, there are 4 phosphorus. I mean there are 31 times 4 gram phosphorus. So in 100% how much? You calculate 43.7%. Thank you dear students. Please subscribe, like and share my channel. Thank you.